This is the study guide for the spiral number 4 on FDP and sign implementation. We're just going to run through these, do a little bit of a review on some of these concepts. Convert the following fraction into a decimal. In order to convert a fraction to a decimal, this line means divide. Which number goes to the inside? The top goes to the inside, top goes to the top goes to the inside, 8 on the outside. 8 does not go into 3 when we add decimal and line them up. 8 does go into 30 3 times, it's 24 with 6 left over. Zeros drop from underneath the radical. 8 goes to 67 times, it's 56 with 4 left over. Zeros drop from underneath the radical. 8 goes to 45 times, it's exactly 40. So the answer is 0.375 or 375 thousandths. Moving to the right, convert the following percent to a decimal. These are ones that you don't want to be lazy on. 3.5%, the decimal moves 1 2 times. So 0.035 or again, tenths, hundredths, thousandths, 35 thousandths. Over here, convert the following decimal to a percent. Again, another one to not be lazy on. Moves 1 2 times. 104%. You can think about these two circle things move 2 times. Convert the following fraction to a percent this time. Make sure we're reading. The top number goes on the inside. 9 on the outside. Does 9 go to 5? No, 9 for decimal. Does 9 go to 50? Yep, 5 times. That's 45 with 5 left over. Zeros drop from underneath. Does 9 go to 50? Yep, 5 times, which is 45 with 0 left over. If you notice, it's going to continue to repeat. So the answer is 0.5 repeating. You could put 0.55 repeating with a repeating bar over just the 5. You could put them over both of them. But either way, we want to write a percent. In order to convert this to a percent, it is not just moving it twice and then 5 with a repeating bar is 0%. That doesn't make sense. You can't have a repeating number in the tens place. If you think about it, these are 5s going on forever. So when you move the decimal over to here, it's actually a 55, and then a decimal point, and then there's repeating 5s over there. So the answer is 55.5 repeating percent. This is the only real thing that we would accept. It's not a repeating bar over on numbers to the left of the decimal point. 55. It is 55.5 repeating percent. Convert the following fraction to a decimal, which is sort of misleading because this is actually a mixed number. Let's convert it to a decimal either way. A couple ways that you can do this. You realize it's 2 and 1/6, so you can do 2 and then figure out what your decimal is. Figure out what 1/6 is. 1's on the inside, 6 on the outside. Does 6 go into 10? Yeah, it does. 1 time, that's 6. With 4 left over, 0 drop from underneath. Does 6 go into 40? Yep. 6 times is 36. With 4 left over, 0 drop from underneath. Does 6 go into 40? Yep. 6 times is 36. With 4 left over. If you notice, it's a repeating 6. It's 2.16 repeating could be your answer. Or, what you can do is turn this into a full fraction. Multiply then add, multiply then add. 6 times 2 is 12. Plus 1 is 13 over 6. And then you can divide this one. 13 on the inside, 6 on the outside. Does 6 go into 13? Yeah, it does. 2 times, that's 12 with 1 left over. Does 6 go into 10? Yeah, it does. 1 time, that's 6 with 4 left over. Does 6 go into 40? Yep, 6 times, it's 36 with 4 left. And then you get the repeating part that was over here. Either way, it's 2.16 repeating. Convert the following decimal to a fraction. Now this is a decimal to a fraction, not to a percent. You need to know how to read off the number. Tenths, hundredths, thousandths. This is 82 in the thousandths place, so it's 82 thousandths. Now I do have to simplify. Let's try it by 2, because these are both evens. This is 41 over 500. Now 41 is a prime number, so I know that I'm done simplifying. Moving down to the bottom left, it says to convert to standard form. This number as the exponent does not say how many zeros, it says how many times the decimal place moves. Since it's 7, it moves 7 times. Positive is big, negative is going to be small. We'll deal with that in a second, but a positive number means it's a big, positive exponent means it's going to be a big number. 1, 2, 3, 4, 5, 6. Fill in with zeros like egg crates. 3, 0, 0, 2, 0, 0, 0. The answer is 3,002,000. The same idea here, we take the number 5, we're going to move the decimal place, but since this is a negative number means it's going to make this smaller. If you move it this way, that's wrong. It's 1, 2, 3, 4, 5, 6 times Fill in with zeros like an egg crate. 1, 2, 3, 4, 5, 6. So 0 and 1, 2, 3, 4, 5 zeros, and the number 5. These last two require a bit more work. It says to compare. I can't compare them because they're written in different forms, so let's turn them both into decimals. 33%, that one's pretty easy. Just move the decimal twice, 0.33, or tenths, hundredths, 33 hundredths. Let's compare that to 1/3. Calculus on the inside, 3 on the outside. Does 3 go into 1? No. Does 3 go into 10? Yeah, 3 times 9 with 1 left over, 0 strapped from underneath. Does 3 go into 10? Yeah, 3 times, that's 9 with 1 left over, 0 strapped from underneath. Even if you weren't sure, you can keep dividing. Does 3 go into 10? Yeah, 3 times, it's 9 with 1 left over. So 0.323, or really 0.3 repeated. So which one's bigger? This is 3, 3. This is not 3, 0. This is 3's forever. So when this keeps going 3's, this one runs out and it starts doing zeros. This is 3's forever. So that one is larger. This one is greater than the symbol. And the last one says to place them in descending order, which is going down. So it's greatest to least. Let's convert them all to the same number. 7/9. We're going to divide this. 7 on the inside, 9 on the outside. Does 9 get to 70? Yeah, it does. It's 7, which is 63, and 7 left over, 0 shot from underneath. 9 gets to 77 times. That's 63, with 7 left over, 0 shot from underneath. If you notice, it's 0.7 repeated. 72.5%. Take the decimal, move it 2 times. It's 0.725. 7.2 times 10 to the second, 7.2. Now since it's a positive exponent, it means it's going to get bigger 1, 2 times. That looks like it could be the biggest one. Let's see though. Alright, there's a negative exponent, so 7.9. Negative 2 means it moves to the left, 0.079, and the last one is 7/10. Alright, descending order means which is the smallest. This one's clearly the smallest. 720, which was 7.2 times 10 to the second as the original. All right, now we have decimals. This is 0.0 and this is 0.0, so that's out. This is 0.7, 0.7, 0.7. So let's move on to the next number. What is right here in the hundredths place? 7, of course, but 7 forever. That's a 2. That's a 0. So since 7 forever is the biggest, that's 7/9. That'll be the next biggest. All right, this is 7/2, and this is 7/0. So 7/2 is the next, or 72.5%. Now I got 0.7, 0.7 or 7/10, and the last one is the leftover. The only one that's left with a negative exponent, 7.9 times 10 to the negative 2. This is what it would be in descending, going down order.